Hi folks, my name is Danny Martins. I'm the product manager for SSH related projects within Windows and Azure at Microsoft. And today I'll be showing you how to manage Windows Server via SSH and Arc. So jumping straight into it, today I'm going to show you in about 10 minutes how to connect to your Windows Server without a public IP address via SSH and Arc. So how are we going to do this? First, we're going to enable Azure Arc. If you're not familiar with Azure Arc, Arc allows you to bring the Azure management plane onto a non-Azure joined piece of hardware. And so this could be something where it's your local computer. It could be a machine that's running in a private data center or a machine that's in a different cloud provider. Next, we're going to enable SSH on our Windows Server. SSH has long been the industry standard for remoting. Windows has been the exception. So if you look at connecting to a Linux machine, a networking device, or an IoT device, you're probably going to use SSH to connect to that machine. Historically, WinRM or PowerShell remoting or RDP has been used to connect to Windows servers. But if we look at WinRM is no longer receiving any feature updates, and all of PowerShell remoting's future is based off of SSH. And if we look at RDP, it's difficult to audit the actions performed over RDP. You can't audit a mouse click. Next, we're going to look at how to use Azure PowerShell and native SSH commands to actually connect to that machine without that public IP address. And this is possible using the Arc connectivity back into Azure. Next, I'll show you how to enable a key-based login for administrator. SSH keys are a more secure way of authenticating to your machine compared to username and passwords, which are generally standard for, say, an RDP connection or a WinRM connection. And lastly, I'll show you this a fallback to using RDP access over SSH if you're not really ready to fully commit to transitioning to SSH at this point. So let's just jump straight into kind of our environment. Here, I have a Windows Server 2025 Insider build. This is the latest Insider build. If I look at my local server, we have added an option to enable remote SSH access. And so we'll start by enabling both Arc access and SSH. So when I click to enable Arc, I've already installed the Arc agent just for the sake of time, but we still need to configure it and connect it to our Azure account. So I'll do a quick sign into Azure. Go through my two-factor flow. Great. So I've successfully signed into Azure, and next I'll connect it to my specific tenant, subscription, and resource group. Lastly, I'll add the region. Great, so while this is connecting to Azure, I'll show you that I already have some Arc machines here. So now in the Azure portal, you can see I have 2 existing Arc machines. And once this machine is onboarded, we'll see another machine pop up here. Give it one more second just to show you it's there. We can see it's complete, and we'll refresh one more time. There it is. So now I've onboarded my machine into Arc, and I can see it in the Azure portal. Next, let's enable remote SSH access. When we enable SSH on the machine, this is going to run a PowerShell script to start the SSH service and set the startup type to be automatic. Great, so now we've already enabled Azure Arc on this machine, and we've enabled, I'd say, the SSH server-side component running on this machine. And so if I want to connect, I can open a local terminal experience. So here I have PowerShell running on my local client. We'll minimize out of this RDP view just so you can see that, yes, I am not running on my remote server. So here I can connect to my server by running enter AZ VM. And in this case, I can specify my resource group, in this case, Arc servers, the machine that I've just onboarded, and I'm going to be connecting as an administrator. I've also specified the resource type as a hybrid compute machine because this is an Arc-enabled server. This command can also be used for Azure VMs as well. So when I execute this command, it's going to say, hey, we need to set up SSH connectivity on this Arc server. This is purely for the connectivity that Arc is going to provide. And so here, I'm going to say, yes, I want to enable SSH-based connectivity over Arc to this machine. This is something that's specific for an owner of that resource. If you have someone who has a reader or a contributor access to this machine, they will not be able to enable this. So now that this is running, it's going to try to connect. And if you're familiar with SSH-based connections, the first time you connect to a new machine, it asks you to validate your fingerprint. This is a standard process for SSH or connecting to any machine. And I know that this is the correct machine, so I will say yes to that. Here, I'll supply my administrator password, and I've connected to this machine. And so in this case, I've connected to my new Windows server that I've onboarded into Arc, and I've enabled SSH and able to connect from my local client in probably less than 5 minutes. And so now you have this ability to go from any public machine that you can authenticate into Azure into any of your Windows servers without domain joining, without having to have a VPN or a public IP address on that machine. You can connect via SSH and Azure Arc. If you already have existing automation, let's just say you're in a heterogeneous environment where you have Linux machines and Windows machines, and let's say you already have existing SSH-based tooling. Maybe you're running Ansible. Maybe you like to use SFTP for file transfers. How can you leverage this connectivity, again, without that private public IP address, to be able to connect to that machine? And so we also support an exporting an SSH config file. And so here you can say export AZSSH config, again, supply that resource group name, user login, resource type, and also create an SSH config file. So here I provide a config file path. We'll just create a foo.config. And this will take the proxy that's used in order to connect to my machine that I have packaged as part of Azure PowerShell. And it's going to say for any SSH connection that's connecting to the host, it's going to use a proxy command to be able to connect. And so in this case, if I say SSH and provide the config file I just created, so my foo.config, I supply the resource group of my connection, the machine name, and the user I want to connect as. I can then run this same command. Again, I'll get prompted for my password. And I'm in that same machine just through a native SSH experience. This also applies if you want to use something like SFTP. So I can easily change this and say SFTP and connect to that machine again. And again, here I'll get prompted for the password, but we'll just kill that command now. Let's say instead of having to enter your password each time, you want to set up an SSH key. How do we do that? I already have an SSH key that I use to connect to all of my Arc machines. And so I'm going to create a key variable that has the content of that key. So now I have a PowerShell variable with my key value. And there we can build some remote PowerShell script to add a file in the SSH folder on my remote host with the administrator authorized keys with the value of the key file that I'm passing. So here I will create that remote PowerShell. And now I can go back to that same SSH command that I had previously, and I can just supply this remote PowerShell command. Here it's going to connect to the machine. It's going to make me authenticate with my username and password one final time. And it's going to execute that remote that PowerShell script. Here you can see it's successfully run the one command, and there's 0 failed commands that have run. And so now, if I go back to that original enter AZ VM command, I no longer have to use a username and password. I can just supply the private key file that I want to use to connect. And so in this case, this is the private key file that I use for my Arc machines. I can run this command, and I'm not going to be prompted for a username and password because I've supplied the key into that onto the server. Great. So now we have the ability to connect over a private IP address, and we have the ability to more securely connect without a username and password using an SSH key. And so if you're building any automation that's cross-platform across Windows Server and other environments, you can use SSH connectivity to reduce the amount of scripts and tooling that you have to do Windows administration and Unix administration. And you can merge those to build, I'd say, one automatic processing across both over SSH. Let's say you're not quite ready to move completely over to SSH. You still want to have a fallback and be able to RDP into your machines. The nice thing about SSH is it supports arbitrary port forwarding. And so in this case, we've built a parameter -RDP. And so when I execute this command, it's going to create an SSH connection, but it's going to use that as a tunnel for an RDP connection to my remote server. And so it's opening a tunnel to my remote server, and it's using SSH to connect from my localhost port to my remote server. In this case, it's failed. And we know this is going to fail because just like how we enabled SSH and Arc on my remote server, we have it enabled remote desktop. And so it's expected to fail. So in the case that you want the fallback default to use remote desktop, just enable RDP back on this machine, apply that, and say OK. And we'll run this command one more time. In this case, it's using my SSH key to create that tunnel, and I will be prompted for an RDP authentication into the machine. In this case, I still have to use my username and password for the administrator because RDP does not support key-based login. And I now have a new RDP session connecting to that machine. And you can see the difference here because on the connection, it's showing that I'm connecting to a localhost port, but this is indeed that same remote Windows server that I was connecting to previously. Great. So what have we done? So in the past 10 minutes, we were able to easily enable Azure Arc, enable SSH server component on Windows Server 2025, connect the machine without a public IP address via Azure PowerShell and a native SSH command. You could also use that with other OpenSSH-based tooling. We enabled key-based login, and we've also shown how to fall back to RDP if you need that and you're not ready to fully transition. That's all the time I have today. Thanks so much for your time. If you have any questions, I'm Danny Martins. You can find me on Twitter or message me on GitHub. Thanks so much.
Welcome to Windows Server Engineering Summit. Today I'm talking about disaster protection with SR, storage replica, in Windows Server 2025. My name is Ned Pyle. I'm a Principal Program Manager in Windows Server. You may know me from SMB, DFSR, Active Directory, File Services. But I'm also designer and creator of Storage Replica, which we first released in Windows Server 2016. And we have a lot of big news in that space that I'm going to talk about today. I've only got 15 minutes. I got to be fast. So let's talk enhanced performance, compression, and then I will show you lots of practical demos. Let's go. Storage Replica helps organizations survive disasters. It helps you keep your job. SR is designed for you to be employed. It protects companies, organizations, businesses from gigantic forces outside of their control. And those forces can be earthquakes, hurricanes, wildfires. And they can happen at a city level, they can happen at a regional level, they can happen at a town level. And depending on the size of the organization, that's a big enough disaster that could affect you. Just even the last year, this is National Weather Service data. These are the billion-dollar natural disasters that happened just in the United States in 2023. So every one of these things, whether it's a wildfire or a flood or a tornado or giant snowstorm or whatever, each one of these represents at least $1 billion worth of damage. And SR is here to protect you from that, to give you continuity, to make sure that your place can keep running. So what do we got? In 2025, we have something called the enhanced log. Storage Replica writes data blocks above the partition, I/O blocks, into these logs and chips them between machines, using them to reconstruct the data blocks on another machine. And so the performance of this log is key to Storage Replica's performance. It is the engine. It is the thing that does the replication. And this new enhanced log, we sometimes call the raw log, reduces latency, increases throughput, and is based on a different type of technology. So it requires a new partnership. It is in Windows Server 2025 only, but you can still use 25 servers with SR and in its older mode called CLFS logs on 22, 2019, 2016, anywhere where SR lives. And then there's compression. So Storage Replica uses SMB, you know me from SMB, as its fabric, as its transport. And because SMB does compression, we plumbed SR to do compression. And that can give you really significant network savings. It can save you a lot on inefficient IOs that write a lot of effectively empty blocks of stuff into the data. And so on a crappier network, you can see real significant savings. On a highly congested network, you can see real savings. And this is now in Server 2025 in all of its editions. It was actually shipped in 22, but only in Azure edition. So you may not have been aware that this functionality was there. Now it's available for everybody, for all things. And it's primarily for asynchronous replication. Obviously, SR does synchronous and asynchronous. All right, so this new log and compression and asynchronous gives me, I think, a very viable alternative to using DFSR. And everybody's seen DFSR. It came out in 2003 R2. It's what you use to keep your sysvols in sync automatically. But its custom replication is a very complex, large system of file replication that's been around for almost 20 years. And it's got some real limitations, especially in age, as being a disaster recovery, disaster prevention option. It only works on unlocked files. So locked files, in-use files don't replicate. It's extremely latent, minutes, hours, days latent on changes. It has, at this point, pretty small maximum size limitations just because it was designed for a world that no longer exists. It's extremely slow on initial sync. It's multi-writer, which is advantageous in some ways, but can cause its own set of disasters with data overwrites from multiple users accessing multiple copies of the data at various points in between replication. It has a very complex and rather finicky staging system that requires a lot of tuning and careful math in order to make sure your replication works optimally, and a lot of space reservation in order to make sure that it will replicate at all as your file sets get larger. And because it's so old, again, it's from 2003 R2, it never new things like REFS and newer file systems, it is completely incompatible with them. And really, most of its really significant development ended in 2008 R2. There was some changes in 2012, some smaller changes in 2016, but for the most part, DFSR has just been a maintained product now that's as good as it's ever going to get. So, when could I use Storage Replica instead of DFSR? I need zero data loss, minimal data loss. I can't be dealing with locked files. I can't be worried about replication being out of sync for very, very, very long periods of time. I've got lower latency and higher bandwidth networks, although compression will help here. Ideally, if you're going to push this much data, you're going to want to have better networks. And DFSR was designed to work on modem networks, extremely narrow networks. And I only need 2 copies of the data. As DFSR supported thousands and thousands of copies of the same file, SR just does a source server and a destination server, and that's it. And finally, I don't care about this multi-user case. I don't want users writing to 14 different copies of the file and then a complex algorithm deciding who won. Okay, so let's talk about tackling some of DFSR's disaster prevention failings with Storage Replica. So the initial sync. Here is DFSR, the old DFS management snap-in. Familiar to anybody who grew up on Windows Server 2003. I'm going to go ahead and add a couple of servers here. These are decent servers. They've got all flash. They've got 10 gigabit networking between them on TCP. I'm trying to make this a fairly reasonable case. I'm going to set up replication. I'm going to set up primary. In this case, it's going to be 421. Keep that in mind. And I'm going to set up what folder I'm going to replicate. In this case, it's on the E drive, RF1 folder. And then I'm going to add the other server, which is 423, turn on replication, give it a place to replicate to, and let it rip. And that's sort of an optimistic way of putting things because this is, of course, DFSR. There's not a whole lot of ripping going. So we go look at the event logs, and I find I'm looking for my 4112 event. That's my I've started event. There it is. Okay. So here's where I've initialized the replicated folder. I got a primary member, and I'm waiting for all that data to get pulled by the secondary. So I'm going to the secondary, and I'm looking for a 4102 event that says, I've heard about this, and I'm starting. So we're going to catch this and just watch and see how long it takes. We can see how big this is. I'm replicating about 400 gig of data, about 10,000 files, a mixture of all kinds of files, some big, some small. And so we've been waiting for a while. We're doing 72 gig. Let's wait longer. All right, we waited a lot longer. We waited 3 hours, and it's finally done doing 400 gig. Over 10 gigabit, that's not great. And what's worse is I sort of cheated here on DFSR's behalf. I tuned staging. I made a bunch of little, fine configuration changes as a real, I own DFSR. I'm supposed to be an expert on this. So I made DFSR as fast as I could really make it. Honestly, if this had been an out-of-the-box setup and I hadn't touched any of that stuff, this initial sync, especially with these types of files I was replicating, some of them very large, multi-gig files, it might have taken 24 hours. It might have taken 48 hours to finally reconcile, getting its way, forcing it through the staging and the high watermarks and the flushing operations and all this shenanigans that DFSR does. Anyway, let's get on to the good stuff. Here's Storage Replica. Now, why do I call it the raw log? Check out this volume I just created. It is, in fact, raw. And where we're storing this log, it's actually based on storage spaces technology is where this log is actually kept. And so now I'm going to put in my server. It's 421 again. I'm just picking a different drive. So instead of using the E drive, which is where DFSR was, I'm just picking another exactly the same hardware G drive, another flash drive. And I'll add my other server and pick another drive. And I'm going to set this for asynchronous just because, I'm trying to match up to my use case where it's a file server that I want to be working on, worse networks. I don't need synchronous replication. And I'm probably going to use compression. So it started. I'm watching. Notice I'm using Windows Admin Center for all of this, not gross old snap-ins from 1999. And time has gone by. It's now continuously replicating. And if I go look in my event viewer here, which is in WAC, and I don't need to go wandering off to another tool, I can see here that my replication started at 8:09 and it finished at 8:17. 8.5 minutes is how long it took. That's all. So not 3 hours, not 24 hours, not 48 hours, 8.5 minutes. Not too shabby. And if I was being like cool, I would have used RDMA and SMB Direct and 40 gigabit network cards here, and it would have been even faster. But I'm giving DFSR a fighting chance because I don't want to be super rude. All right, let's talk about just protecting a file. So I'm going to take on my DFSR server, I'm going to copy this big file. It's about 14 gigabytes. And just drop it into my replicated folder on the source machine. And here it's copying. And then it's being, it's going to be replicated over to the other server using DFSR. And so it's taking me, 20 seconds to copy the file here onto the machine. But it's not really protected yet, right? It's got to actually be copied. So let's take a look at this thing. Last accessed at about a minute. It's a helpful little timestamp. So let's go over and look on the other server and figure out how long it took for this thing to show up. We take a look. It's still not here. Should start with an S. Let's just wait a while. We ended up having to wait about 10 minutes. When I open this file, you can see my last access time. It took quite a while for it to show up, actually. Let's try this with Storage Replica. Now, this is not files anymore, so I can't go look at a file, right? It's blocks. So I'm going to go and use perf counters and just use them to let me eyeball the transfer of this particular file. The same file, I'm going to do it again. So I'm going to set my log writes per second. I'm going to set my bytes per second on sent. And then I'm just going to do the same thing, just copy a file into the storage replicated G drive. Let's just copy this thing over here. Here it goes. Now, I'm copying the file onto the disk, but really what am I doing, right? I'm replicating the file onto the other server simultaneously. So this copy, when it's done here, being on the disk, it's done being on the other one as well. There's no 10 minutes. There's no let me unlock the file. There's no, I'm waiting for the staging folder to clear out. None of that nonsense. The IO here is the IO on both machines. And you can see it's going. I'm getting a pretty good throughput there. And when we're all said and done, I'm waiting for this to finally finish flushing out. Here we go. 35 seconds. Not bad. Not 10 minutes. Not 2 hours. Not a week. 35 seconds. So here's the old log and the new log. CLFS log versus raw log. Exact same operation. How much better is it than, say, Windows Server 2022? Copy my file. Everything's happening at the same time. You can see that I'm actually getting more consistent throughput and higher throughput on my raw one. By now, if you haven't guessed, it's the top one is where raw is going. And so it's cranking and cranking, consistently cranking, no dropouts, moving along consistently, doing about 500 megabytes a second. That's looking good. This, by the way, is synchronous replication this time. And when it's done here, flush, 32 seconds. The other one's going to keep going. This is still being protected pretty fast, way better than DFSR, but it's taking much longer to be done because this is the old log from 2022 server. And there it is, 48 seconds. So a vast improvement over the old storage replica, not just over DFSR. So better performance, better network usage, excellent disaster protection. It's in all editions of 25. It's included. There's no extra price. There's no special subscriptions or anything. And I have written an entire article on being able to go and do a migration you can use from DFSR to Storage Replica. It's on the FileCab blog. And I want to thank you for your time. Please enjoy the rest of Windows Server Engineering Summit.